Welcome back to Math 103. This is video number 17 on apportionment. So in our example where there are 21 seats to apportion, but the rounded standard quotas sum to 22, should we use a modified divisor less than or greater than the standard divisor? Right? We can't use the standard divisor itself because that's what led to 22 seats, which is the wrong number of seats to apportion. Well, the reasoning process here is based on our cookie cutter model. We produced too many cookies, and therefore we correct that by using a larger cookie cutter to end up with fewer cookies. So we need a modified divisor greater than the standard divisor. How much greater? Well, this gets into the whole process of guessing and checking. In practice, for purposes of this course, I will give you at least a few suggestions for what modified divisor you might guess that is larger than this standard divisor. In particular, I propose 665,000 as the modified divisor. That is indeed greater than the standard divisor, which was 661-something thousand. Right? And our goal now is to see if that results in rounded modified quotas that sum to 21 seats. Right? So our job is to compute modified quotas based on this new modified divisor. Now, modified divisor means the same thing in this context as it did for Jefferson's method. It is a number that we divide each state population by instead of the standard divisor. Okay, so 6.3 million has to be divided by 665,000, and that turns out to equal 9.474. That is the modified quota. Whereas Jefferson automatically rounded modified quotas down, Webster checks which is the nearest integer. In this case, that is 9, but he's checking the 9 point something to see whether the point something is less than 0.5 or whether it's 0.5 or greater. Right? So the nearest integer here is indeed 9. And we go through and do the same computation for each of the other populations divided by 665,000 to see the resulting modified quota and then round it. And behold, here are the results. Here are all the modified quotas and the resulting rounded modified quotas, rounded to the nearest integer. So just to be clear where exactly all of these numbers came from, for example, where did this 1.805 come from for New Hampshire? That was the result of taking the population, 1.2 million, and dividing by the modified divisor of 665,000, and sure enough, that equals 1.805. So having done this for each state population divided by 665,000, we get each of these modified quotas, we round each one to the nearest integer. And lo and behold, miracle of miracles, they add up to exactly 21 seats as we'd hoped. So what does that tell us? It means this is the Webster apportionment. We have found the Webster apportionment of these 21 seats. Before we consider another example, let's sum up Webster's method. So first consider the standard quotas. Always start with the standard quotas and round each one to the nearest integer. If the sum of those rounded standard quotas happens to equal the number of seats to be apportioned, then great, we're done. We have just found the Webster apportionment, and that's it. But if the sum of the rounded standard quotas is not equal to the number of seats, then we need a modified divisor. In particular, if the sum of those rounded standard quotas is less than the number of seats, think too few cookies, and so not enough cookies, we need more cookies, then we have to find a modified divisor less than the standard divisor. So think we need a smaller cookie cutter to remedy the fact that there are too few cookies. A smaller cookie cutter will produce more cookies that we need. So the way that works is that dividing by the modified divisor nudges the quotas higher. If, however, the sum of the rounded quotas is greater than the number of seats, then we need a modified divisor which is greater than the standard divisor. So think too many cookies means that we need a larger cookie cutter to end up with fewer cookies at the end of the day. The idea being that dividing by a modified divisor should nudge the quotas lower. So now we're going to look again at one of our previous examples based on 38 seats and populations given in this table. So before going on to the next video, answer the following question, which is typical of a homework or exam question on Webster's method, including a typical hint. So the question is, find the Webster apportionment of 38 seats given the information here in this table. So you know that there are 38 seats, and you know the populations. You might even be given the standard quotas, although you could figure them out yourself if you needed to. And the typical hint is that you're told that one of the following modified divisors will work. So this one right here is the standard divisor, and that's on your list of potential divisors that will work. And if not that one, then one of these modified divisors will work. So it's left to you to figure out which. Now before you do this, my advice always is, first ask, do we need a modified divisor at all? In other words, maybe the standard quotas themselves will already lead to the correct apportionment. If not, then we need a modified divisor, and then you should ask yourself, should that modified divisor be greater than or less than the standard divisor?